Hello everyone, I am Onik Das, a PhD candidate in the Department of Civil and Architecture and Engineering at the University of Wyoming. Today I am going to present our paper titled Prediction of Lane Change Maneuvers Using the Sharp to Naturalistic Driving History Data, a Machine Learning Approach. Welcome to my presentation. Lane changes are one of the most frequent and complicated driving maneuvers occurring on roadways. According to the National Highway Traffic Safety Administration, lane change maneuvers are responsible for around 540,000 motor vehicle crashes in the United States in 2018. During lane change process, a driver requires many streams of information, and absence of this precise information associated with lane change maneuvers could increase the probability of a lane change crash. Although most of the literature has a plethora of work on lane change prediction, there is a lack of studies that utilize a data fusion approach based on data availability. In addition, very few studies investigated the ability of machine learning approaches for predicting lane change maneuvers in a naturalistic setting. Therefore, the primary objective of this study was to develop reliable and efficient lane change prediction models using the high-resolution trajectory level Sharp to NDS and roadway information database datasets. The data preprocessing and preparation started with the collection of Sharp to NDS strips from the VTTI. To effectively identify lane change events, we developed an automatic algorithm. After annotation and manual verification, we extracted necessary data before lane changes and generated parameters. Finally, roadway geometric characteristics from the RID and driver characteristics from the Sharp to survey questionnaire responses were merged to NDS time series data. The final dataset comprised lane changes and no lane changes within 5 seconds. We considered 80% of this dataset for training and validation and the remaining 20% dataset for testing. The table summarizes the selected features associated with different data sources used in this study. We considered several widely used machine learning classifiers, including classification and regression trees, random forest, extreme gradient boosting, adaptive boosting, support vector machine, k-nearest neighbor, and naive Bayes to develop the lane change prediction model. Based on the insights from our previous study, we introduced 6 sets of features from the final dataset as shown in the table. In order to extract necessary features in each feature set, Boruta feature selection algorithm was utilized. In these figures, the green and red box plots indicate ZS scores of important and unimportant features, whereas the blue box plots represent ZS scores of a shadow feature. To explore the importance of the used features, we applied XGBoost algorithm to support and validate the results of the Boruta algorithm. The prediction performances of the machine learning models are comparatively assessed in terms of accuracy, recall, precision, and F1 score. The green color represents the best performance and the red color indicates the worst performance observed. After evaluating all performance measures, we found that XGBoost model obtained the best and balanced prediction performance. We also investigated computation costs and probability of predicting lane change maneuvers of the machine learning models. And we found that XGBoost model had low computation costs and reasonable probability values with high confidence. The detailed performance of the XGBoost model was measured in terms of confusion matrix and ROC curve. As shown in the figure, the XGBoost model had very high true positive rates and very low false negative rates. Also, the AUC values are found to be greater than 0.9, representing the high accuracy of the XGBoost model in predicting lane change maneuvers. Finally, we developed a simplified XGBoost model for each feature set and found that the simplified XGBoost model performed similarly to the full XGBoost model. In summary, we introduced 6 sets of features in this study based on data availability. We employed a wrapper-based Boruta algorithm to extract relevant features. For each extracted feature set, we adopted 5-fold cross-validation approach to tune the parameters of the classifiers. Considering the detailed performance evaluation, we recommend to use XGBoost model for predicting lane change maneuvers. A simplified XGBoost model was then developed for each feature by removing several highly correlated features. The proposed lane change prediction model could be helpful in trajectory planning for autonomous vehicles and could be used to develop more reliable, advanced driver assistance systems in a cooperative, connected, and automated vehicles environment. With that, I would like to conclude my presentation. I will be happy to explain more if you have any question. Thank you very much for listening.